can say this value is a plus minus 8. Similarly, root over of minus 64 is the problem, which is the 64 into minus 1. We know that the root over of 64 is plus minus 8, but any number the square that not equal to minus 1. So we can find the root over of negative number. But Euler mathematician, they develop iota, which is denoted by I, where the value of I square equal to minus 1. That means this is the imaginary number which square equal to minus 1. So in the place of minus 1 you can write I square. So root over of minus 64 is plus minus 8i. So using this value I square equal to minus 1, we can find the value of I to the power any number. Just like example, IQ. So this one you can write I square into I to the power 1, where I square value is the minus 1, minus 1 into I, this is equal to minus I. But when you find the value I to the power 4, that value is the I square square, which is the minus 1 to the power 2, which is the plus 1. But when I to the power any large number, that how to find using this I square value? There is the formula I to the power any number that divisible by 4. If any number divisible by 4, the remainder is 0, either 1 or 2 or 3. So when I to the power any number is divisible by 4 and remainder is 0, then that number is I to the power this remainder 0, which is equal to 1. Or you can say I to the power 1 remainder, that value is I to the power 2 remainder, that value is I square, which is equal to minus 1. So when the remainder is 3, that value is IQ, which is equal to minus I. Using the value of I square equal to minus 1, we can find the value of I to the power 123. So using that formula, which number is divisible by 4, remainder is what? If 123, that divisible by 4, the remainder is 3. So remainder 3 means I to the power that remainder IQ, which is equal to minus I. Similarly, in case of I to the power 3, 1, 4, 2, 5, 6, which is a very large number, but we can find very shortly that this last 2 digit 56, which is divisible by 4, that means remainder is 0. So I to the power that remainder 0 is equal to value 1. Similarly, in case of I to the power 3, 1, 2, 4, 5, here last 2 digit is 4, 5. This 4, 5 divisible by 4, then remainder is 1. So I to the power 1, that is equal to I. Similarly, in case of I to the power 2, 5, 6, 6, then this last 2 digit number 66, which is divisible by 4, remainder is 2. So I square equal to minus 1. Sum of the 4 consecutive powers of I is equal to 0. That is, I to the power m, I to the power m plus 1, I to the power m plus 2, I to the power m plus 3. This is equal to 0. Why? That is the proof. I to the power m, this is the I to the power m, plus I to the power m plus 1, that we can write I to the power m into I to the power 1. Similarly, I to the power m plus 2, you can write I to the power m into I to the power 2, because base term is the power 2 by addition. So I to the power m plus 3, you can write I to the power m into IQ. So here, overall I to the power m is a common, then you can write in bracket 1 plus I square plus IQ. But we know that value 1 plus I square is the minus 1, IQ is the minus I. So 1 cancel, I cancel, I to the power m into 0, which is equal to 0. So using these properties, we can find the value of this one. I to the power 1 plus I to the power 2 plus I to the power 3 plus I to the power 4, which is equal to 0, because this is the 4 consecutive number. Similarly, in case of I to the power 20, I to the power 22, I to the power 24, I to the power 26. This is also consecutive even number. So this also equal to 0. Similarly, I to the power 31, I to the power 33, I to the power 35 plus I to the power 37. This is also consecutive odd numbers, which is equal to 0.